Next, we're going to look at numbers 17 through 20 from the exercises in section 3.4. There's a scenario that's listed, and then there's actually several questions that follow. I believe they start with number 15, but we're going to look at these four in particular. So a student was trying to figure out how many hours a day students at their school tend to spend on coursework, not including when they're in class. And the student took a random sample of 150 students at random. They found the average daily study hours in the sample was 2.23 hours with a standard deviation of 1.05 hours. So again, before we do anything else, let's figure out what are the observational units, what is the variable, and what kind of variable is that. So I strongly recommend that you pause the video and work these out for yourself, and then come back and see how you did. So the observational units are, actually going to abbreviate here, students at the school. And again, if you said the 150 students that were surveyed, that is a beautiful, perfectly correct answer as well. The variable is number of daily study hours. Again, that's outside of class. Notice it's not the average or the mean number of daily study hours. It's not an average. What is asked of each student is how many hours a day do you spend on schoolwork? And then we are going to take an average, or the student already took the average for that sample. Now that is a quantitative variable. It's something that is measured and it has units of hours. Another thing that's going to be useful for us now that we know the variable is quantitative is to talk about what is the parameter, including its symbol. So when the variable is quantitative, the parameter symbol is mu, and so that is an average or mean, either one is fine, you don't need both, number of daily study hours. And that is for all students at the school. So note to self, the parameter is a summary of the entire population, which is all the students at the school. The student researcher took a sample of 150 students and found the average or the mean for that sample. That would be our statistic. So while we're at it, the 150, that's n, our sample size. The 2.23, that's x bar, the sample mean. And 1.05, that's s, the sample standard deviation. What we're going to do is create a confidence interval using the 2SD method, which again, remember, creates a 95% confidence interval. So we are trying to estimate what the average might be for the entire school. We know what the average is for this sample of 150 students, and we're going to use that to come up with this interval to estimate what the average might be for the entire population of students at the school. Okay, so knowing that our variable is quantitative, we can create our interval by taking x bar plus or minus 2 times s over the square root of n. So again, something that tends to trip students up is we're doing 2SD, but the SD that we're multiplying by 2 is not the sample standard deviation s, it's the null distribution standard deviation s over the square root of n. So make sure you recognize when your variable is quantitative, you have two different standard deviations to contend with, the sample standard deviation s and the null distribution standard deviation s over radical n. All right, so we're going to plug in the numbers here. X bar is 2.23, s is 1.05, and n is 150. So once again, I strongly recommend that you pause the video and try to work through this calculation for yourself. I'm going to take it one step at a time. First, I'm going to calculate the SD, 1.05 divided by the square root of 150, and you should get 0.0857. Then my next step is to multiply that by 2. And when you do that, I don't really need a parenthesis here. When you do that, you should get 0.1715. And using my color scheme from earlier, note to self that this value is our margin of error. So on your formula sheet, you see that one of the ways to denote or write a confidence interval is as a statistic plus or minus a margin of error. And that's the way the interval is written on this line right here. Statistic 2.23 plus or minus a margin of error of 0.1715. Then my next step is to actually do the plus or minus. That is, I take my statistic minus the margin of error, and separately I take my statistic plus the margin of error. And I always put the subtraction on the left and the addition on the right so that my interval limits come out in the correct order. And when you do the subtraction, you should get 2.1026. When you do the addition, you should get 2.3574. So again, if you're not getting these numbers, let me know so we can figure out what's going on, and you can make sure you know how to do it for a quiz or a test. So we found our interval. It didn't ask us to, but just for the practice of it, let's interpret the interval. So we always start with the same phrase. We are blank % confident. In this case, our confidence level is 95%, so that's what we'll use. That, and again, I'm going to fudge a little bit. The average or mean number of daily study hours for all students at the school, I'd write in that entire phrase, that's the parameter description, is between, and here I'm going to say 2.10 and 2.36 hours. So I've rounded my confidence interval limits. You don't have to round them, but again, we want this to be understandable to the average person, so we don't want tons of decimal places. Also, notice I didn't convert these to percentages because they're not proportions. My variable is not categorical, it's quantitative, so I can simply report the confidence interval limits, the endpoints as we call them, in my interpretation. I don't have to convert anything from a decimal to a percent. Okay, now I would like us to calculate the midpoint of this interval. So again, based on what's on your formula sheet, to get the midpoint, we take the high right endpoint of the confidence interval plus the low left endpoint of the confidence interval, and then divide that by 2. Again, strongly recommend that you do the calculation for yourself and make sure you're getting the correct answer. And what you should get when you do this is 2.23, and notice that is our statistic x bar, sample mean. So the sample mean statistic is the midpoint of the confidence interval. And then I'd like us also to calculate the width of the confidence interval, and keeping my color scheme of doing the width in green. That is the high value 2.3574 minus the low value 2.1026. And if you do that subtraction, you should get, whoops, I think I wrote some wrong numbers here. Sorry, I'm going to go back for a minute. I apologize. I have the wrong numbers. Oh my goodness, and I don't want to do this video all over again, so I apologize for my mistake. You should get 2.058. Whoops, let me switch from green. You should get 2.0585. So if you were saying to yourself, oh my gosh, that's not what I got, what did I do wrong? You were right. I'm so sorry. And then when you did the addition, you should have gotten 2.4015. So sorry about my mistake. So over here in my interpretation, I'm 95% confident that my parameter mu, the average of daily study hours for all students at the school, is between 2.06 and 2.40 hours. Whoa, and then when I'm finding my midpoint, I should have been taking 2.4015, the high value, plus 2.0585, the low value, adding that together and dividing by 2. The good news is I do still get 2.23, the statistics, so I got that going for me. All right, let's try this width again. If we take 2.0, if we take 2.4015 and subtract 2.0585, we should get a width of 0.343. Okay, so again, just double check that. I apologize for my error, and hopefully if you thought you were doing it wrong, now you know in fact you were doing it right. When we do the subtraction of the high value minus the low value, we get a width of 0.343. And then, just as a double check, the margin of error we can get by taking the width and cutting that in half, dividing it by 2. So if you take 0.343 and divide it by 2, in fact you should get 0.1715, which is the margin of error that we came up with earlier.